Hello guys, so today we are going to see the Leetcode question and you're watching Expert Panda on YouTube. So let's start understanding the today question, that is 540, a single element in a sorted array. Okay, so this question 540 saying that you are given a sorted array, right? We have given sorted array consisting of only integers, right? Where every element appears exactly twice, right? except one, which appears exactly once. So we have to return the single element that appears only once. Okay, so you must run in O log n, and space complexity should be O of 1. So let's suppose this is given, we have, right? So if we will represent this one in array, it will look like 1 1 2 3 3 4 4 8 8, right? So let me re-represent this into array. So this will look like this, correct? So as you can see, now it is very easy to find the element that is not duplicate, right? How? So see, 1 is coming 1, so 1 should be one more time in the array, and that is there. Now if you see, leave it to, now we see 3 is already in the array 2 times. Now 4, we are seeing that it is coming 2 times. Now we can see that 8 is there, right? So sorry, it is there here, and then we can say that it is here also. Okay, here. Now only one element is left, that is 2 we have, and that's why this is the output we are seeing, right? Means the element that we have given in the array is all the element are means coming twice. There will be only one element in the array that we have to return as output. Okay, and we have to take time complexities as O of n, right? So there is a very simple approach if you will not consider this constant, that is O log n, right? Means we can use a brute force approach, and we can use a linear search to check whether every element in the array until we find the single element, right? So in the algorithm, what we will do, we can starting the element with we iterate over every second element and checking whether or not the next element in the same as the current, right? We can check, right, the same as the current. If it's not, then we know that this must be a single element, right? So if we get as far as the last element, we know that that is it must be a single element, and we need to treat it as a special case after the loop, because otherwise we will going over the end of the array, right? So I'll suggest let's go to do the brute force approach, right? And we'll implement O log that is a time complexity will be for the brute force approach, time complexity O of n, and a space will remain O of n, O of 1, we can say, right? So let's see how we can implement this one. Okay, zoom little bit. Okay, so I'm here, and you can see that what we can do, we can write two things. So first is our for loop, right? So nums we have given, so what we will do, we will make a loop, for loop, and we'll traverse from int, that is our index equal to we'll start from 0, and then we'll say I, that is index should be less than equal to, we'll go to the array last length, that is our you can say length, and we'll do -1, then we will reach to our last length, right? And we'll take consecutive plus, right? So that plus equal to, we can say 2, we will add 2 value consecutive, we can say we will add we will move to index, right? Second index. Then you will check if, then we can say if num of that is nums of, right? Nums of what, we have I, right? So if nums of I not equal to what, not equal to nums of I plus 1, the next element, right? So if we'll get I, then I plus 1 should also have the same value, right? If that is not, means we have to return that element, right? What we have to do at that time, we will return nums of I, because this element doesn't have duplicate twice, it is not coming twice in the array. Then what we will do, we will return what? Nums, and then we will pass nums dot length, and we'll take -1, so that we will return the value. Okay, well, now what I'll do here, let me compile this one. Yeah, if we'll submit this will not work for us, so that what we will do, we'll go to our next complexity, right? This is working, right? But this will not accepted. Let me see, array on out of bound exception is coming, right? Runtime error. So now this is done. Now what we will do here, this is the thing we have done, right? Now we will do, we will reach to the next element, the next approach, sorry. Now we should go to the next approach, right? And we should implement this one, and this is our brute force approach, right? So what I will do, let me remove it, don't worry. Let me remove this one. Okay, so let's understand the another approach that we have is a binary search, right? So why we will use the binary search? See, so binary search makes sense to try and convert the linear search into a binary search, right? So in order to use, you can say, binary search, we need to be able to look at the middle int item, and then determine whether the solution is at the middle item, or in the left, or to the right. So the key observations to make it that starting after appearing, right? You can say starting array must after odd number, right? Add odd length, you can say, because it has one element appearing once and other appearing other twice, right? So we will take one, what we will do, if we talk about the algorithm, what we will do, we'll take low and high, and this is the lowest and highest index, right? Let me give me 1 minute. Yeah, you can write here, right? Let me zoom Leetcode. Yeah, so what I'm talking about, see, I'll take another color. Yeah, so what we will I'm talking about, let's suppose we have this one, right? So what we will do, let's suppose we are going to 1 1 4 4, next we will, what we have, 5 5 6 6 8, let's suppose there is a 9 9, right? This is the array we have, let's suppose. Okay, I'm taking just for example, so that this will help us to understand the binary search. I think you already know, but if you do not know, you can consider this example. That's a very good example, this one. Okay, now think, if we want to find the duplicate, right? Not duplicate, that's coming only one time, right? So what we will do, right? First we'll take low and high. Okay, so there will be a low and high index, right? So we will remove a pair from the center. We'll start from remove from the center. Okay, from here, and we are at left with a left subarray and right subarray. Let's suppose this is our 0 1 2 3 4 5 6 7 8 9 10. We have 10 element, right? So if I'll talk about this is our let's suppose this is our, you can say low or high, right? So if this is low say or left say, and this is our high. Okay, so what we will do first of all we'll take mid, right? So I'll take mid equal to low plus high 0 plus 10 by 2 equal to 5. So what I will do, I'll say this is our mid element, this is our mid element, let's suppose. Okay, so what I will take the mid element, I'll suppose that there is two things. The first we have, this is our left sub array, this is our left sub array, and this part is our right sub array. Okay, this is our right sub array. So one is left sub array, another is right sub array. So what we will do, we will start deleting or removing, you can say, from the mid. Okay, so every pair we will remove from the center, and we say we are left with the left sub array and a right sub array, right? So like the original array, the sub array containing the single element must be odd length, right? And the sub array not containing it must be even length, right? It can be possible, right? So taking a pair out of the middle, then calculating with which side is now odd length, we have the information needed for binary search, right? So now if you see that this part, if you consider, we have what, even number, right? And this part what we have, left right side what we have, odd number, correct? So that I am talking about. Okay, so what I'm talking about is that the sub array containing the single element must be odd length, right? So the sub array not containing it must be even length, that is left. In our case this is left, right, and this is our right. So right contains odd, left contains not odd, it's even. So by taking a pair out of the middle, right, then calculating which side is now odd length, right, we have the information needed for the binary search, right? So now we will consider what, 6 6 8 9 9. We know that, correct? Because we have this information that our right side we have odd one, means this must contain our element, right? So what we will do, on each we can say we will start by setting low and high first initially, then the low and high index you can say will take inclusive of high right of the array, and then iteratively half the array until we find the element until one element left, right? So we know that if there is one element in each search, we must have the this one. So either we can do the same thing we can do, right? Like we will do half by this one, so we will get this one, right? Means I'm saying the same thing, we have did the same thing here. Now we will say this is our low, this is our high, right? 0 1 2 3 4, right? Now what we will do, this is our middle element, right? So if we'll talk about the middle element, we don't have the pair of this one, right? So this is the single element, right? And rest of the element is we have the pair, right? We have. So to either you remove this one or you say this is the element that we have, right? So what I'm talking about, so we know that if there is only one element in the search space that we are talking about, there is only one element, right, here on the mid. So we can it must be the single element, and so it should terminate the search, you can say, correct? If there is only one element in the search space, right, it must be a single element, and so it should terminate the search, right? So on each loop iteration, we find the mid and determine the odd or evenness of the sides. Save it in a variable that is called, you can half are even, right? And by then looking at which half the middle element's partner is in the last element of the left subarray or first element in the right subarray, then we can decide which side is now you can say remain low order, or you can say if you set the low or high, right, to cover the part of the array, we now know that the single element must be in, right. So the trickiest part is to ensure we update low and high correctly each time, because based on the value of mid and half even number that we have, right, that we will take one variable that we can say halves even, you can say half even, right. So we have the halves are even number and mid we have, right. So based on that we will take our low and high correctly, right. So this diagram that we have seen here, right, should understand the cases that when we solve the problem, like it should it's good to draw the diagram and think really carefully about avoid off by one error, and avoid using the guess and check approaches, right. So case 1 is what that we have seen, that we have deleted from here, right, this one. So this part we have removed, the left sub array we have case 1. Okay, give me 1 minute. Yeah, let's suppose we have case 1. In the case 1, the mids partner is to the right and the halves were original even, means the right side becomes odd length, and because we moved mid partner from it, we need to set low to mid plus 2, and so that the remaining array is the half is the part above the mid partner. Let's suppose the case is that we have 1 1 4 4, then what we have 5, we have 5, we have, and then in this case we have 8 and 6 and 8 and 8. Let's suppose this element we have, right. So what I'm talking about, if this is our array, let's suppose if this is our array, we will consider like this, right, and give me, let me change the color. Okay, so what happened if you consider the mid one, so I'll remove this mid one. Okay, because see, this is our mid. Okay, this is our mid, so I have removed the mid, this pair, right, the pair I have removed, right. So the new low, because this has been removed, so new low is what, this one, you can say this is new low, and this is our high, right. Previously it was here, that's why I have not written here, but now it has been moved to here to here. Okay, so this part is removed, right, because we are not considering this one, because there is no odd is there, right. Yeah, this is no odd is there. Now here is two pair, one 8 8 and another pair doesn't have, only one single element we have, that is 6, right. So this is the approach we can say. So this case we can say the mid partners is to the right and the half were original even, right, half is original even we have, and mids partner is half original, right, in the right, you can say. Another case is, right, mids partner is to the right and half were original odd, right. So this was even, now this time it will be odd, right. So how we will do that? Let's suppose give me 1 minute, let me change the color. Okay, so in the case 2, let's suppose what we have, 1 we have, then we have 1 we have, then we have 4 we have, then we have 5 we have, right. In this case we have 6 6 and 8 8 9 9, let's suppose. Okay, so if we will represent this one into array, so this will look like this array. Okay, okay, now this is done. Now what we will do, we'll check. See, we know that this is our mid, right, so I'll directly remove this one. 6 6 is our mid, right. So what happened, this has been removed, right, this pair is removed. Now the green part that we left, previously we have chosen this part, right, this part. Now we'll say that this, our green part is this one that we are talking about, right. Now what happened, we have 1 1 4 5 5, this one, right, and now we will not consider this one that we are talking about, right? This one. So now new mid is, previously mid was here, right? Previously mid was here, now mid is here. So now we have to update new mid at this position, right? Previously mid was at here. Understanding? So here we are updating our low, here updating we are low, here updating our mid, you know. So this case you have to understand, right? So the first case was like the mids partner is to the right and the halves are original even, right? And the second case is what? The mids partner is at right, but the half were odd, right? So this half is now odd, right? And here we are getting even half part, right? Half this one. So the first part you can say. Now the case, let's suppose one more case is possible, right? Case 3. Okay, so let's understand the case 3. We'll take this one. Now we have element. We'll take one array. Let me write first array. I'll take this array that we can say 1 1 4. Okay, next I will take 5 5, and then we can take 6 6 8 8. Now the mid element is what? At the mid, and that is nothing but these two. This is removed, right? This, our mid was here, correct? Now the new high we can say is at what position? New high at this position. Okay, because we are not considering this part. This part is odd, so new high is this one, so we will take this one, right? And so we can say the mid partner is to the left now, right? And the half were original even, right? The half is original even, right? But this is now in the left side. Till that we have right side, now we have in the left side. Okay, next we can say one more condition is there, that is our case 4. Okay, okay, now we have another case we can consider also. Let me take another color. I'll consider this one. Okay, now we have 1 1 4 4. Now we have 5 5 6 6 8 9 9, the original one. Okay, so in this case we know our mid is right. Let me write this one. Okay, so our mid is at what? This position. Okay, I have to change the color. Okay, our mid is at here, correct? So previously the mid was here, right? Now new low is what? This position, at this position, and high will remain same at the last. Okay, so in this case what is even? The mids partner is to the left and halves were original odd, right? Half we have is original odd, so we are not considering this part. This part we will consider here. Here we will consider this part, right? Here we will consider this part. Where the odd is coming, that will consider, right, each time. So in this case you have understand, first case what we have to do, we have to update our new low. In the second case we have to update new mid, and the third case we have to update new high. In the fourth case we have to update new low, right? So these are the possibilities that we have seen in the fourth cases, right? So now let's understand, let's go to the code section and we'll try to implement this one. Okay, the first thing what we have to take is we will take one we can say we'll take one low, right? And this low is our, you can say we'll start from 0. Okay, the first that we will take is low equal to 0. Then we'll take one high, and high is at what? we can say at the last position, right? Initially it should be nums dot length and minus 1, right? So this is the position we have. Now what will happen? Low is set and high is set. Now we will make while loop and we'll say if low is less than high. I should write first low high, otherwise I will get confused. Okay, so I'll take low, and then we'll say low is less than what? High. Okay, if high is greater than the low, till that we will go, right? And we'll say that we'll find our mid. So mid is we can calculate. There is a way we can say low plus high by 2 also we can say, but to get the exact low mid, what we will do? Low plus high minus low. One of the video I have already explained this, how we will what is the meaning of this one, right? By 2. I think you already know this one. Otherwise, if you'll do this one, put the some values is there, you will understand. Okay, so the mid we have got now, right? We'll take one boolean that we are talking about, halves. We can take halves, right? Not halves, and our array, right? Halves are even, we can say halves are even, and this is nothing but our, we'll consider as a boolean. Okay, we have taken one variable and we'll say that if how we will find this one. So rather than we'll do high minus low. We will do high minus low and we'll take more or less 2, right? We used to find if this is equal to 0, means this is odd or even, right? We used to find in the childhood, right? So we'll get our, the halves are even or odd, that will come. Now 4 cases we have to take care, that for that we are doing, right? Now we'll consider if nums at mid plus 1, if the mid element is equal to nums at mid, the next element of the mid and mid plus 1 both are same, right? Then we will say if these half are even comes, right? If these halves are, you can say true, right? In that case we will say we have to update our low, and we have seen that in that case low is what? Mid plus 2. We have to update our low to mid plus 1, mid plus 2 at the last index, right? We have already seen this one. Now what we will say in the else condition, we will say our high, we have to update our high, and high is what? If that is not the case, if that is not even, then we will update our high. If this is odd, means we have to update our high. High is now mid minus 1, correct? Now we have to update our high. Next time we'll check this is done, right? Next time what we will check, in the else condition we'll check if else, if, and we'll check here if the, let me go to here, we'll consider this one. So here we have taken what? Mid plus 1 is what? Is at here, this value is equal to mid, both mid pair is equal, right? Now we'll say if mid minus 1 is equal to mid, and similarly this one. So if this is the case, we will first check this one, and we'll say if this half is what? Even, right? If this half is even, then we will consider high equal to mid minus 2. We have to update our mid. If not, means else, and we'll say in the else means we have to update our low equal to mid plus 1. Correct? This is done. Now what we have updated this one, this else. Now what we have taken first if mid plus 1 equal to mid, if mid minus 1 equal to mid, and then we have to take one more condition, that is for else, right? And in this case we will return what? Nums at mid, the element that we have. Otherwise, if that is not the case, right, then we will return here, return nums at low. Okay, let me submit this one. Getting error somewhere. Okay, so let's consider again. First of all, what we should do, we have taken low equal to 0, then we will take high at the last position. We'll check low is less than high, then we will find our mid. Mid is low plus high minus low by 2, you can say, and then we'll take one boolean value, right? And this boolean will check high minus we have taken mid, right? High minus mid, you can say, not low, high minus mid. This is the error we have, and then we'll check the first condition. We'll check on the if it is at the mid pair is equal, if mid pair is before that is less than, and else condition. Yeah, now submit this one. Yeah, this is working fine. So let's me go to here. So these are the first condition, fourth condition we have taken, right? The first condition what we have taken is in the case 1, if we are at the mid, right? If the mid elements are equal, right? In that case, what we have to do? We have to consider, we have to update our low, right? In the second case, if we have got our mid, right? So then we have to update our mid, right? In the third case, what we have to do? We have to update our high, and the fourth case we have to update our low, right? So these 4 conditions we have just implemented here, right? Right here, and we have done this, right? So this is the these conditions. This approach will take O log n, right? And time complexity will remain O of n. Okay. TC is equal to O log n, and space complexity is O of 1. Okay, so thank you guys, thank you so much. If you like this video, please hit comment and subscribe this channel. One more approach is there, and if we'll talk about this one, let me just what we have to do. We have let me remove this one. Okay, this part is done, right? Okay, the another approach that we have to just optimize this you can say binary search on the even index, right? Only. So when we are talking about binary search on events, right, index only, means this is more elegant approach than the last one, right? Both are good solutions. The previous that we will see, this was also good, but in this case our institution is the first element is at the first
even index not followed by its pair. But we use this property in the linear search algorithm, where we iterate over all the even indexes until we encounter the first one not followed by its pair. So instead of linear searching for this index through, we can binary search for it, and after the single element, the pattern changes to be being odd index, you can say, followed by their pairs. So this means that single element and all the element after it are even indexes not followed by their pairs, right? Therefore, given any even index in the array, we can easily determine whether the single element is to be the left or to the right. So what we will do, we'll need to set up a binary search variables, and we have to loop so that we are considered even indexes, and the last index of the odd length array is always even, so we can set low and high to be the start and the end of the array. So we need to make sure our mid index is even. So we can do this by dividing low and high is usually way, but then determine by it that is 1, you can say. If it is 1, then it is odd, right? And this also ensure that if we have an even number of the even index to search, in that case we are getting the lower middle incrementing by 1. So we would not work if it's lead to an infinite loop, as the search space could not be reduced in some cases. So then we check whether or not the mid index is the same as one after. If it is, then we will know that the mid is not the single element, and that our single element must be at the even, right? So before doing anything, let's find our low is less than high, right? Then we will find our int mid equal to, we have low, and we'll say our high is there, right? High minus low by 2. If you not understand this one, you can ping me in the comment box, I'll help you there. Now if we will make the condition, if mid, what we can say, mid is have let's 2, right? So we'll find the, if equal to 1 means that is odd, okay? So if mid we are getting reminder 1, means we have to update mid minus first, we have to reduce. Then we'll check if we have nums, right? We have nums at what? Mid. Nums at mid equal to, we'll say it's a pair, right? Nums at mid plus 1. If it is equal to, then we'll say low equal to mid plus 1, right? Low is mid plus 2, right? We previously used to do mid plus 2, right? So we'll consider if both are equal, then we'll update our mid, right? Mid plus 2, because mid we have already element and mid plus 1 already have, so then we have to update our low at mid plus 2, right? We have to escape to one pair. In the else condition, we'll say our high is at now at mid, if not equal to, correct? If mids are not equal, then high is at mid. This condition is done. Now while is done, right? Finally we will return this one. So say we will return nums at low. This should work. And in this case, what is happening? We are taking we are not going to all the element, right? We are going to half of the element, right? but this is equal to O, this is equal to O log n only. Okay, because if you are doing half, it's still the worst case can be possible, right? Let me run this one. Let me submit this one. Yeah, this will accept. So this approach is very easy approach, right? In which what we have to do, we have to we are doing the same binary search like that we have did in the last, and but except we are only binary search half the element. We are not going to the full element. That's why I'm saying log n by 2, right? So rather than going for all the element, you can do by the half of the element, and it will, your time complexity will in actual it will reduce to less than O log n, right? It's so in the actual you can say log n by 2, but that is also equal to O log n, right? So the space complexity will remain same because the same approach we are using, and we are not using any extra space, that is a constant space we are using, right? So if you like these videos, please hit comment, subscribe this channel for more videos, and thank you so much guys for your support. Thank you so much.